Abey, the tradesman's choice. Disaster strikes the Australian industrial city of Newcastle, New South Wales. A strong earthquake takes 12 lives and damages around 10,000 buildings throughout the city. Worst hit, the Newcastle Workers' Club, left in ruins by the quake. The city faces a repair bill close to $1,000 million, due in part to poor building practices and inferior materials exposed by the earthquake.
In December 1989, the city of Newcastle here was struck by an earthquake estimated to be of magnitude 5.6 on the Richter scale. Despite the relatively small magnitude of the earthquake, damage was widespread, with a total damage bill in excess of $1 billion. 13 people were killed and over 100 were injured. The majority of damage was to unreinforced masonry, resulting from poor building practices, inferior building materials, bad planning and sheer ignorance of masonry behaviour. Unreinforced masonry, although strong in compression, is a brittle material with low tensile strength. Its ability to resist high wind or earthquake loadings depend on this strength, particularly its bond strength. It also depends on effective support and attachment to other elements of the building. Masonry is a relatively dense material too. Since earthquake-induced forces are a function of the mass of the structure, larger forces will be induced than for many other structural materials. The performance of brick ties was highlighted as being one of the main contributing factors to this sad scenario. And it's a scenario that has the potential for many repeat performances if these warnings are not heeded and these ignorant attitudes and poor practices are not changed.
The rebuilding and repair work around Newcastle has taken years. Building contractor Colin Weaver has been closely involved in the rebuilding.
Yes, I've been repairing university buildings. These were built with federal government money, presumably well supervised, and yet they exhibited all the normal faults you'd associate with low quality construction. Some of them encountered a high degree of damage.
What sort of faults did you come across?
Well, the two main ones would be lack of tying action, that's within the leaves of the wall and of masonry to the building frame, and the lack of bond between the masonry units and the ties.
You mentioned lack of tying action. Can you be more specific?
Oh yes, we found some ties, even in fairly modern buildings, completely corroded away. Others were absent, they hadn't even been built in. Some ties had been built in and bent out of the way and bent back down again, which had weakened the tie and made it too flexible, those sort of problems.
And what about bonding?
In some cases we found a complete lack of bond between the mortar and the masonry units.
And the bonding that was there, was that up to standard?
No, definitely not. Well, we didn't expect to find a very good bond in the older buildings, and we weren't surprised there, but we were surprised with some of the newer buildings, only 1 year old at the time of the earthquake. One of them had zero bond throughout its construction.
What were the reasons for this?
The abuse of additives, far too much air in trainers and the like, the use of fire clay, the substitution of fire clay for lime, for example. Basically a lack of understanding about why mortar really sticks to bricks.
What are the lessons that we can learn from the Newcastle earthquake?
Oh, we've all got to lift our game. Designers, builders, everybody. Let's take the designers, for example. They're still specifying galvanised wire ties in a coastal or industrial environment. They're just not suitable.
What should we be using?
Well, stainless steel's the best alternative. And it's cheap. Cheaper than most people think.
Any other lessons?
Yes, attention to detail all round. The quality we thought we were getting just wasn't there. We've really got to go back to the basics and start very slowly and carefully, and we've got to learn what we're actually doing.
The Newcastle earthquake taught the industry some extreme lessons in brick wall construction. Traditionally used ties, like these, are useless in coastal or industrialised areas. Bending ties out of the way to make the bricklayer's job easier only weakens them. And we haven't even examined the effect on mortar bonding. Abey designers heeded the lessons from Newcastle with a range of brick ties that dramatically improves the integrity of masonry walls and makes walls easier and, in many cases, less expensive to construct. And you don't need an earthquake to prove their value. Abey makes a range of ties to secure different types of masonry walls. Brick to brick and block to brick. And for brick veneer walls too. Timber stud to brick, steel stud to brick, and tilt slab to brick. Compare the Abey two-piece tremor tie with ordinary cavity brick ties. These ordinary ties include suspect galvanized coatings that can result in corrosion growth up to 5 times the original size. Imagine the consequences with this heavy conventional tie. Then there is the problem the bricklayer faces. It's always been simple to bend ties out of the way to avoid hindrance and injury. But that weakens the tie and the mortar. But Abey has solved these problems with this, the two-piece tremor tie. The anchor is installed into the first wall, leaving only a small engaging slot exposed. As the second wall rises, this arm is simply connected and pressed into the mortar. The result? Easier installation with less likelihood of injury during bricklaying, and a flexible anchor that can handle growth and shrinkage in both walls. In this simulation, you can see how the unique link feature of the tremor tie works. The correct cavity distance is maintained continuously. Abey tremor ties are rated medium duty and are made to suit 50, 75 and 100 millimeter cavities. And they're available in stainless steel or galvanized steel finish. Look how simply tremor ties work in a brick wall too. Again, no sharp protruding edges and nothing to bend out of the way. Galvanized tremor ties are actually less expensive than conventional wire ties. Abey makes a brick veneer tie that is 3 times stronger than conventional ties, that also allows for timber shrinkage and brick growth that can occur in this type of construction.
This is the Abey Sheriff face-fixing tie, which has been designed to conform to Australian standards. It has a very narrow shank, so that any mortar that drops down the cavity does not stick onto it.
This tie is not only stronger than ordinary brick veneer ties, but it is made from just half the amount of steel. It's rated light duty. It's also available as a side fixing tie. By screwing this tie into place, you reduce the vibration that can dislodge a tie from the mortar. But what about frames wrapped in foil insulation? Here, the insulation is in place. This is another breakthrough in brick veneer construction ties, the Abey veneer tremor tie. It's another two-piece tie that not only makes bricklaying easier, but it helps keep the insulation in place. It's rated medium duty to suit 50, 75 and 100 millimeter cavities. Abey encourages the use of screw fixings to minimize the effects of hammer vibration when using nails, especially in light frame construction. Ties are supplied with either nails or screws. With the plates measured out and fixed, bricklaying and tie fixing becomes a simple, frustration-free process. The plates can be fixed in consultation with the carpenter prior to the start of brickwork, allowing the bricklaying to continue unimpeded. Note again that the linking feature of these ties allows for any differential movement between wall and frame. The veneer tremor tie can also be used to fix a brick wall to a concrete backup or tilt slab wall.
In this situation, we've already fastened the backing plate to the concrete backup wall to the heights necessary for the bricklayer to suit his brick gauge. Now let's see how the ties work. This is the tie, which fits quite simply into the backing plate by being inserted vertically and then turned down into the bed joint. It has 2 distinct advantages, one especially for the bricklayer, in the sense that there is nothing sticking out from the wall to catch his arm or his trowel during his laying actions. The second advantage is that it allows for differential movement between the brick veneer and the backup wall. It's important to remember to lay the bed before fitting the ties to make sure that mortar completely covers the tie.
These ties are designed for use in steel frame construction too, and they're available for cavities of 50, 75 and 100 millimeter widths. No other ties match these ratings or cavity widths. The two-piece construction makes them ideal in high wind or seismic areas. The backing plate offers another advantage. It acts as an insulation fastener. This is the coal tie, another innovative Abey product. It's available in stainless steel or in galvanized finish. The Abey coal tie gets around the problem of fixing brick walls to universal columns. It does away with welding or screwing fixing devices to the steel column. The jaws simply slide onto the column flange. A good practice is to slide it back about 10 millimeters to allow for any expansion. The crimping and the holes in the coal tie securely key it into the mortar. Some columns have a thicker flange width. The coal tie can accommodate varying flange widths through the action of this unique pivoting point here at the base. Watch how the coal tie can easily lock onto this larger universal column. The jaws are spread and the coal tie is pressed home. Watch again how the unique pivoting action allows the coal tie to deform exactly to match the flange thickness.
Now let's look at the Abey alligator ties, which have been designed to connect a steel and concrete column to a brick wall. The tie itself consists of three parts, a backing plate and two jaws which act like alligator jaws to grip into the mortar bed. The tie itself, whilst providing lateral support, still allows for long-term and thermal growth of the brickwork. Now let's have a look at how the ties work. Obviously the gauge is marked on the column before the brickwork is started and the backing plates are fitted to the column. It's important to remember to fit the fixing screw in the centre of a brick course.
The Abey alligator tie will keep this wall vertical at all times. And yet the V shape allows for normal brick growth and expansion. See how the control gap is maintained. The alligator tie can also be used to fix non-load bearing walls to ceilings, still retaining that control gap and allowing for movement with the sliding action. And there's another feature.
It's important to note that the alligator ties maintain the correct gap of the control joint. The importance of correctly installing expansion ties in control joints cannot be overemphasised. Not only has the brickie got to maintain a clear space between the two panels of brickwork, but he also has to make sure that the tie itself is in alignment with the wall. This tie, this Abey tie, has a flange which lines up with the end of the brick, thus maintaining its alignment throughout the wall.
Even with thermal movement or brick growth, this tie effectively holds the two brick leaves in correct alignment. See how the tie actually flexes across the control gap. This is a conventional expansion tie. In extreme cases, it may create a potentially damaging cross-hatch effect, and this can be the result.
This old-style tile is difficult to maintain in alignment with the wall and is quite easily moved. With long-term and thermal brick growth, this can result in damage to the wall. These ties are also very expensive in stainless steel.
Once in place, any mortar droppings should be cleaned from the ties before caulking strips are fixed. These ties are available in stainless steel and galvanized steel. The range of Abey brick and masonry ties provides important advantages. They're simple to install, and importantly, they're available in stainless steel. Any building construction within a coastal area should incorporate corrosion-resistant stainless steel ties for maximum effectiveness. Just as incorrect brick specifications can lead to salt damage like this in coastal areas, ordinary mild steel brick ties can result in hidden damage to brick walls. Recent Australian studies have shown that salt fallout from the ocean can carry inland in excess of 30 kilometres, or 18 miles. So stainless steel is imperative here. So too in areas close to industry, where corrosive elements in the atmosphere can attack ordinary steel and weaken buildings. Abey designers have produced these products in stainless steel to incorporate strength with a competitive low price. This is the smarter tie, because it supersedes those heavy and often expensive ties with a lighter, better lasting stainless steel product that meets the current building standards. Little wonder that Abey masonry ties have become the tradesman's choice. When it comes to the crunch, Abey ties really work.
Are you still batching your mortar using a shovel? This no longer meets the requirements of AS 3700, and more importantly, the mortar that you're mixing is probably more likely 10 or 12 to 1 to 1 rather than 6 to 1 to 1. The correct way is to batch with buckets or a box. 6 buckets of sand, 1 of cement and 1 of lime, keeping the lime and the cement in the same buckets in the dry state so that it doesn't stick. If you have to use any additives at all, make sure that you use them strictly in accordance with the manufacturer's instructions. If you're using an air entraining agent, 25 millilitres per bag of cement is the correct amount. That is, for a mixture of this size, about half this capful. Remember, the correct way is to batch with buckets, and that way it'll ensure that you get a consistent strength mix every time. And now I just want to talk about some important points in relation to damp-proof courses. As you can see, we've already fitted this damp-proof course on this on-slab brick veneer construction. And the important points to remember are these: that when the flashing has been fitted, to make sure that it can be seen on the outside of the brickwork and not to set it back 20 or 30 millimetres from the face. This can allow the damp-proof course to be bridged and moisture to travel up through the face of the work. With the incidence of salt attack today, this can become a very real problem. The other important point to remember is to turn it up at least 2 courses and to fasten it securely to the bottom plate. As you can see, we fastened it here with nails to make sure that there's no chance in the future that when the building is finished, that the damp course can fall forward and allow any moisture coming down the back of the brickwork to actually penetrate the internal surfaces of the building. And remember, when using embossed plastic damp course, to make sure that the minimum thickness you use is 500 UM. The most important thing with on-slab damp-proof course construction is to make sure that the weep holes are correctly formed to drain any moisture that may gather on the back of the brickwork. And the correct way to do this is simply by pulling the mortar back 20 to 30 millimetres from the brick you've just laid, and then lay the next brick with a dry perp. You will notice that the mortar does not extend back into the weep hole space, leaving an absolutely clear channel for any moisture to exit. At the bottom of every window opening, a sill flashing is fitted to prevent the entry of water. This is the second line of defence. The first line of defence are the sill bricks themselves, the flashing providing the second line of defence. The flashing should not be laid any more than halfway across the bed joint to ensure a good bond between the sill bricks and the brickwork below. That it extends at least 100 millimetres past the window jambs, and that it must be drained. Weep holes are normally formed in the flashing itself by the use of bolts which are laid in the mortar bed and removed before the mortar hardens.
Subfloor ventilation is vital. Installing this Abey brick-size vent opening at regular intervals will keep an airflow moving beneath the floor and help reduce the effects of damp and rot.
Talking about joint finishes, This is the raked or recessed joint finish, which is probably the most popular in Australia today. Due to our strong sunlight, it gives a pronounced shadow effect on the brickwork. But from the engineer's point of view, it's probably the poorest joint finish, because we remove the top layer of mortar, allowing easy entry of moisture into the joint finish, and also any pollutants can rest on the arises of the bricks to be drawn into the mortar at a later stage. This is the round iron joint, produced using a 12mm steel rod. This is a very good joint finish because we produce a hardened surface on the face of the mortar, resisting the entry of water and any pollutants from the atmosphere. This third joint finish is known as the weather strut and is produced using the trowel. From its name, it's pretty obvious to see that the weather, and rain especially, would be directed straight off the face of the brickwork and discharged down to the ground. Probably the best joint finish we can produce. We cannot overemphasize the importance of spacing brick ties. They should be spaced no further apart than 600 by 600 millimeters, or 5 ties per meter squared. However, all around edges and openings like windows and doorways, the spacing must be reduced to 300 by 300 millimeters, or 10 ties per meter squared. Remember, when ordering ties for your building, brick veneer is rated as light duty. The minimum rating for cavity construction is medium duty. If your building is in a coastal area or within 3 kilometers of an industrial area, make sure you only use 316 marine grade stainless steel.
Abey, the tradesman's choice.